Reminded me to record today. The lecture.
Oh, you should record it.
Yeah, too late. All right, let's start with a simple problem that you guys got in the homework, or a similar one to what you had in the homework. Let's say we had somebody tell us that sine theta equals 1/5. And they ask us, oh, if sine theta is 1/5, then what is cosine theta? What is tangent theta? What is cosecant of theta, right? What is cosecant? 1 over sine, right? What is secant theta? 1 over cosine. And what is cotangent of theta? So how do I start solving this question? Yep. But before the Pythagorean theorem, we have to draw the triangle with the corresponding side lengths, right? So we'll do that. I'll call this my theta. And then which side is the 1? Opposite, and the hypotenuse is 5. All right, so what is the adjacent side?
The square root of 26.
What?
What does it say in the parentheses?
Continued,
Square root of 24.
which is simplified.
Square root, or 2 square root of 6.
Good. Hide you. All right, we just used the Pythagorean theorem to find that, 2 root 6. All right, so what is cosine theta going to be? Cosine theta is going to be our adjacent side over the hypotenuse, right? So we're going to write 2 root 6 over 5. Tangent theta is 1 over 2 root 6, right? Opposite over adjacent. And we have to rationalize this, right? So we're going to write root 6 over 12. Cosecant of theta is 1 over sine theta, so it's 5. Secant theta is 1 over cosine theta, which is 5 over 2 root 6, and rationalized, that is 5 root 6 over 12. Is that right? I think so. And then finally, cotangent of theta is 2 root 6, 1 over tangent, right? Are we all good on this? So this was the homework. All right. Now let's say somebody asked us, what is, given the fact that sine theta is 5, or 1 over 5, what is cosine pi over 2 minus theta? Cosine of pi over 2 minus theta.
Sine 0. Or wait,
What is pi over 2?
90.
Sorry, I didn't mean to write 90. Gave myself away. Nobody correct my mistake. Yep, pi over 2 is 90 degrees. So which angle in this diagram is pi over 2 minus theta?
Right angle?
Yeah, it's this one, right? This one is pi over 2 minus theta. Right? Because these two angles have to add up to 90. This angle and this angle have to add up to 90. So that means that this angle is pi over 2 minus theta. Okay? And identifying that this angle is the complement of this angle, right? Complementary angles add up to 90. Identifying this helps us define what is cosine of pi over 2 minus theta, right? Because now cosine pi over 2 minus theta is just the adjacent side, or the new adjacent side, over the hypotenuse, which is 1/5. And what is that equal to? That's equal to sine of the original angle, right? Sine theta. Do we agree? So this is one of the first relations that we'll establish for today. And that's simply that cosine pi over 2 minus theta is equal to sine theta. Okay? Something we can memorize. And similarly, sine pi over 2 minus theta is equal to cosine theta. right? And this just comes from the fact that, sine theta is opposite over hypotenuse. And we just use the kind of geometry of the right triangle and the geometry of complementary angles to establish that these things are true. Okay? Now we can also establish several other relations. Let's draw a right triangle again. So we have our theta here. This is pi over 2 minus theta. This is our, let's call this A for adjacent. Here is O, here's H, right? So what is sine theta? O over H, very good. And what is cosine over theta? What is cosine theta?
Adjacent over A.
Thank you, A over H. And then what is cosine pi over 2 minus theta? Yes, sine theta, which is O over H, right? Because cosine pi over 2 theta is just the adjacent here, the new adjacent, right, over the hypotenuse. And then, of course, sine pi over 2 minus theta is equal to A over H as well. So these are the relationships between our cofunctions, the complementary angles. Now we also have, okay, next question is, what is secant theta?
H over A.
Very good, H over A, because it's 1 over cosine, right? Secant is 1 over cosine. And then what is cosecant of theta?
H over A.
No,
Wait.
H over O.
H over O, because cosecant is 1 over sine. How about this one? What is cosecant of pi over 2 minus theta? Very good, H over A. Because cosecant of pi over 2 minus theta is 1 over this, right? 1 over sine pi over 2 minus theta. So that's H over A. And similarly, secant of pi over 2 minus theta is H over O. So this allows us to establish our second relationship, which is that secant theta is equal to cosecant of pi over 2 minus theta. We can keep going. Tangent theta is equal to what?
Opposite over adjacent.
Thank you, over A. I'll just run through these. Cotangent of theta is A over O. And then cotangent of the complementary angle, pi over 2 minus theta, is also over A. Right? And then tangent of pi over 2 minus theta is A over O. So this allows us to write tangent theta is equal to cotangent pi over 2 minus theta. And then finally, we also have from before, right? Sine theta equals cosine pi over 2 minus theta. So these are what we call the cofunction complementary relations. I don't know if that's the real name. I just made it up right now. And we call it that because basically the cofunction of a complementary angle is the same as the original function. Okay, and we call it a cofunction because there's a co in front of it, right? Sine becomes cosine, secant, cosecant, tangent, cotangent. So that's a good way to remember it. Whenever there's a co in front of the original thing, then the cofunction of its complement is the same as the original thing. Okay? You might have a few homework problems about this. Questions? Okay, next is a very important relation that you guys need to memorize. Tangent theta is equal to sine theta over cosine theta. Maybe you guys already know this. right? This is super easy to figure out, right? Because, right, what is tangent equal to? It is equal to opposite over adjacent. Yeah. Opposite over adjacent. And sine theta over cosine theta is equal to opposite over hypotenuse over, what is it? Adjacent over hypotenuse. And if we multiply both top and bottom by hypotenuse, then that gives us simply opposite over adjacent. So super easy to show. Tangent theta is just sine theta over cosine theta. And this is going to be a very important fact when we prove different identities. Questions? Are we all good with the slide? Next. Next is the Pythagorean identity, which states that sine squared theta plus cosine squared theta equals 1. Okay, also must memorize. It's pretty easy to memorize, right? Okay, and by the way, when I write sine squared theta, this is the notation that I'm going to use, but this is equivalent to saying sine theta squared. So I'm squaring the entire function, and a kind of shorthand notation that mathematicians use is they just put the exponent in front of the sign instead of writing the whole parentheses and putting it outside. Okay? So that's what that means. And the reason that this is called the Pythagorean identity is because this is very easily reducible to the Pythagorean theorem. Okay? So if we have our triangle, theta here, adjacent, opposite, and hypotenuse, then what is sine squared theta? That's just going to be opposite over hypotenuse squared plus, and then cosine is adjacent over hypotenuse equals 1. And does anybody see how we can simply reduce this to the Pythagorean identity? Theorem, I mean?
Opposite plus adjacent, or both squared equals 1. And
No. How do we manipulate this into the Pythagorean theorem?
Oh, we multiply both, we multiply everything by height.
yeah,
No.
adjacent.
Hypotenuse squared, right?
Okay.
Makes sense?
Square root everything.
Nope,
then
nope,
multiply
nope,
by height.
nope.
No.
You're not allowed to square root this, right? What you do is, this is just this, right? Opposite squared over hypotenuse squared, adjacent squared over hypotenuse squared equals 1. And then you multiply both sides by hypotenuse squared. If you multiply both sides by hypotenuse squared, then you have the Pythagorean theorem. Okay? And so this is how we prove this Pythagorean identity. Yeah, Liam?
Could, instead of using the Pythagorean, or the Pythagorean identity, could we use just the theorem instead?
What theorem?
The Pythagorean, or Pythagorean theorem?
Like this?
Yeah, the,
Use it for what?
I don't know.
I mean, this is the relation in terms of the trigonometric functions, right? There are no trig functions here. So the point is we want to be able to understand how sine and cosine relate to each other. And this is the relation that they form. It's called the Pythagorean identity. Okay, so pretty much armed with these two relations, the first being the Pythagorean identity, and the second being this tangent identity. This allows us to prove pretty much any trig identity that you'll encounter in today's homework. Okay? Any questions about these two for now? Then let's do our first example problem. Please prove that 1 plus tangent squared theta is equal to secant squared theta. Please prove. Ideas?
subtract 10.
Is it 10?
tan
Oh, it's yeah.
on both sides, and then you get 1 equals secant.
Turn it. Draw a triangle. Draw a triangle.
Do this without any triangles, just using the two relations we just found.
Wait, so secant is opposite.
Yeah.
We're recording this right now, right?
Yes.
Oh, invert tan squared.
Invert, what does that mean?
Or I mean, what was it?
Invert.
Negate tan squared, because secant squared is the negation of cosine, right? So that
You mean the
becomes
reciprocal?
1 over, yeah, the reciprocal. So 1 over tan squared theta equals cosine squared theta.
That's not true.
I'm not sure.
Wait.
I'm confused.
No, they
Huh?
saw the two
We need to
versions.
isolate one. What do we keep it?
Doesn't matter. I can keep it there for now. Any ideas? No ideas?
You write it down.
Come on, somebody can get it. One high truth?
Oh, wait.
Wait,
Oh, tan squared theta equals cosecant squared theta over secant squared theta.
That's not true.
What?
Okay, come on,
that's
guys.
Straight from the identity.
What did we just learn? What that tangent theta equals?
Sine theta
Oh, just
over
wait,
cosine
wait,
theta.
How about we use the things that we just learned?
Yeah, so this is equal to
Opposite, not
cosecant.
opposite.
Wait,
Secant.
oh yeah.
Hypotenuse
Uh,
is-
that's not
You have
correct.
sin theta
Secant,
squared.
wait, secant isn't hypotenuse of the opposite?
Oh, that is true, yeah. But where's the one?
Oh, I forgot to write it.
Okay, what we do is we plug in what we just learned, literally just learned. Tangent theta equals sine over cosine. 1 over sine theta, sorry, 1 plus sine theta over cosine theta squared. And then what is secant theta? Thank you, 1 over cosine theta.
I didn't.
Then what? Next step.
This square or times and everything, so then it would-
Times by, multiply both sides by
cosine.
log.
What?
Did somebody say log? Okay. Anyways, we multiply both sides by cosine theta squared, right? And that just leaves us with the Pythagorean identity. And we're done.
Very close.
QED. Does that make sense?
Oh,
What we just did? Yeah.
What are you saying? How close?
the heck is that?
Not really.
No, I was pretty close.
Okay, so this is how we go about proving these kinds of trigonometric identities. We just try to replace it with some things we know, and then finally get it into a final form that we believe is true. Okay.
How does the right side become 1?
I multiplied both sides by cosine squared theta.
Wouldn't that become
Yeah,
like?
the one on the
Wouldn't that
top.
become like? Oh yeah. I was gonna say it would become like 1 to the 4th, but that's just 1. So
Mm-hmm. Okay, next one. For you guys to redeem yourself. Okay. Can you guys prove this, please?
Now it's too much.
Redemption time. Somebody give me a first step.
distribute the left side.
Expand. Good. So this is a difference of squares, right? So that's just cosecant squared minus 1. Next step, please.
You have 1 over sine on the first side.
What is 1 over sine?
That'd be for the cosecant.
Yes, so we need to use language. Cosecant theta, substitute it with 1 over sine theta. 1 over sine theta squared.
Squared.
Okay, what's next?
Tan, or 1 over tan. Theta.
Okay,
All that.
replace cotangent theta with 1 over tangent theta squared.
Squared.
Next step, please. Anybody?
Then you,
By what? Sine theta?
Oh, put them over the
Uh,
same side.
Okay, we can put them on the same side. We could do that. But I'm looking for somebody to say something better.
um, square everything, so have 1 over sine square theta, and then,
Square everything?
yeah, or not square everything, sorry, sorry,
Why'd you add 1 over tangent? Not negative.
Sorry, you're right. I hide you. Found my mistake. Wait, I think I wrote the. Did I write the problem wrong? Yeah, sorry, changed my mind. Not gonna do this step. No, you did correct. You did catch my error, so that's a high true in this class. Okay, the step that I wanted you guys to say is replace tangent theta with sine over cosine. Okay. Pretty much any time you guys have these identities and you see tangent theta, that's pretty much always the first step. Replace tangent with sine theta over cosine theta. Okay, and so what is 1 over sine theta over cosine theta? That's cosine theta over sine theta. And so we get this. Okay, next step, please.
times everything, or.
Thank you. Multiply both sides by sine squared.
Theta.
So that gives us 1 minus sine squared theta equals cosine squared theta. And we're done.
And one of those.
QED. Do you guys know what that stands for? I forgot. Quod erat demonstratum or something? Don't know. Any questions here?
Speak Latin.
Nope. I can read New Testament Greek though, not Latin. Okay, give you guys another one.
Mr. Nye,
Yeah.
how did you go from like the original problem to cosecant squared theta minus 1?
Cosecant squared. Oh, I just this is a difference of squares factorization, right? So when we expand this, it simply becomes cosecant squared minus 1.
Oh,
Mm-hmm. Okay, any other questions? All right, next one. Give you guys a tricky one. Not that tricky. You can do it in a few seconds.
So this is the trickier one?
Yeah.
The other ones were easy?
Yeah, the other ones were easy. So. So please prove this. Thank you. Well, not that
Turn
tricky.
all the
I don't know.
tan into sine theta over cosine theta. And then for cotangent, it's going to be the reciprocal, so it's going to be cosine theta over sine theta. And then,
Okay, we can do that as a first step. It's a little tedious to do it as a first step, but we can do it. It's no problem.
and then
Sine theta. Huh?
What do you mean multiply both sides of tan theta?
Okay, sure, we can do that. Just to make it the fractions less annoying.
yeah, fraction theta.
Because I know how skilled you guys are with fractions. You know,
Wait,
don't want to create those problems for us. Okay, so maybe now we can try to rewrite everything in terms of sine and cosine. So tangent theta is sine over cosine. And then cotangent of theta, right? That's 1 over tangent, so that's going to be cosine over sine. All right, 1 1 over tangent, so cosine over sine. Then we have a tangent theta, so that's sine over cosine. And then we have that multiplied by, cosecant squared. And we know that cosecant squared is 1 over sine squared, right? Because cosecant is 1 over sine. All right, this is starting to take some shape. We can simplify the left side to be one denominator only, which would give us, right, sine theta over sine theta. So multiplying top and bottom of the first fraction by sine, and then multiplying top and bottom of the second denominator by cosine. And then the right side simplifies to 1 over sine theta cosine theta. And then the left side simplifies to sine squared theta plus cosine squared theta over sine theta cosine theta. And we're done.
Wait, are you making all the denominators the same?
Mm-hmm.
Oh. Okay. No, it's.
Make sense? Any questions?
No, I have a question. Wait,
Maybe I
I
can
need
help you.
one more question, because I have.
Okay. Pause.
You want the
Yeah.
denominators, so the bottom of the fraction to be the same, so you can add all this stuff together.
Wait, but yeah, but like, how did you do that?
So you times each fraction by a number that would be able to make the denominator all the same.
Hmm?
So for that,
What?
you times
Easier problem?
sine
I already gave you the two easy
theta
ones.
over sine theta,
Sorry about
Can
that.
you make an easier one? You like the easier one?
1
It's hard to make them any easier than this.
times anything with this little number. And
Well, like you
for
think of
that,
another easy one.
the
Yeah, I
cosine
thought of the
theta
two
over
easiest ones I could think of, and everything gets harder from those two.
cosine theta over sine theta.
The previous two ones we did were the easy ones.
Because that's all
Yeah.
one, so he can get that one, and then for the one on the left, or on the right, each.
Okay, here's the easy one.
I get it now.
Easy.
I see what you did.
If you guys want an easier one to try, just do this one.
Wait, I can still write it.
Just try proving that first.
Just secant.
Yeah. Tangent theta times cosecant theta equals secant theta. Are we all good with this problem?
No, I'm still writing.
Okay. So first thing to do is write everything in terms of sine and cosine.
Okay. I think I have it now.
Cosecant was just cosine over sine.
I think I got it.
Cosecant is 1 over sine.
What?
I think I understand it.
Is cosecant 1 over cosine?
Cosecant is 1 over sine.
Oh, sorry, secant.
Secant is 1 over cosine.
Yeah, that's easy.
Yeah, it's not a hard one. Just some simplifications.
Just, Did I get a high shoe or something?
No. If you solve the previous one, then yeah.
Wait, do we make everything the same?
It just becomes 1 over cosine.
What do you have right now?
I have sine theta over cosine theta times 1 over sine theta
Yep.
equals 1 over cosine.
That's correct. So now you would just try to cancel things out, and you should be about done after that. So you see how on the left side of your equation, sine is both on the top and the bottom of those two fractions? Yes, because you're multiplying them, you can cross them out.
So then do I just get cosine?
So why you do that, you're saying
Huh?
times it.
I just get cosine theta.
You're left with 1 over cosine theta on both sides, so you're done, right?
Oh, yeah.
That's how you solve it.
Is 1 over
All right, if you guys finish this question, then go ahead and start on the homework.
And then cosine theta.
Trig is fun, right? I love trig.
So you like trig?
Yeah. Well, not the later units of this. Some of the later sections of this unit are pretty painful. But this part of trig is fun. Just simple proofs.
1 over cosine equals 1.
I actually pushed back the test by a day because one of the sections was so hard. I wanted 2 days for it. This is the easy section. So 4-1 through 4 is like the calm before the storm, kind of. Yeah.
Dude, if you were struggling last night, then you're really.
Are you here today?
Yep.
Yeah, that was 22 questions. No, that was at 22 questions, but it was really like 100 questions. Each question was like
It all seems that.